My name is Bob Pearce. I'm the Director of Strategy, Architecture, and Analysis in the Aeronautics Research Mission Directorate. And the panel is going to be on the topic of the new NASA Aeronautics vision and strategy, and more importantly, how we're turning that strategy into implementation. So even though the panel session said, why is our new strategy? I do have one chart on why, but most of it's going to be on this is what the strategy is, and this is how we're beginning to implement it. And so with me today are our four program directors in ARMD, and I think I'm going to do something I've never done before. I'm going to actually introduce them twice. I'm going to introduce them now as the program directors they are, and then I'm going to introduce them a little bit later as the program directors they are going to be in a couple of months. So to my immediate left is John Cavolowsky. He's the program director for the Airspace Systems program. To his left is Jay Dreyer, who's the program director for the Fundamental Aeronautics program. Ed Waggoner is the program director for the Integrated Systems Research program. And finally, to the far left is Doug Rohn, who's the program director for Aviation Safety. So with that, I'm going to the way we're going to run the panel is I'll give a few minutes, somewhere around 15 or 20 minutes on the strategy and how we're turning that into implementation, and then I'm going to turn it over to the program directors to give about 10 minutes each on the new program structure, and then we'll open it up to Q&A with the audience. So let me see if I know it. So this is the chart on why the new aeronautics research strategy. So I think as many of you in the audience probably know by now, we have developed, aeronautics has been developing over the last couple of years, this new vision and strategy. And really, you know, when Jay Shin, sitting in the front here as the associate administrator, wanted to go down this pathway, it was really with the full recognition that aeronautics had a very solid set of partnerships. It was delivering relevant results to our partners and our customers, and it was having the impact that was planned in and desired for the mission directorate. But it was clear that, you know, the world was changing, and that we need to change with it. I think it's, as I reflect on this last week in the conference, you know, I think this conference really reflects some of what aeronautics was, you know, we were seeing. I mean, this conference still reflects the depth of physical understanding we are still developing within aviation and aeronautics, and turning that into code and turning that into new technologies and new products and so forth. But it's also reflective of the fact that in fact, I guess Glenn Roberts said this morning that there were 42 states, but 46 countries represented here at the conference. So that's part of the dimension that I think we're seeing, that there's a lot of R&D going on across the globe, and we need to be cognizant of that and to make sure we're staying appropriately, as we believe, appropriately ahead of the curve in terms of doing the research and developing high impact technologies. So that rising competition in international R&D that we're looking at. Clearly there are big challenges to mobility, energy, climate that are here with us today and are certainly going to be with us for the foreseeable future. And then as was reflected, I think pretty significantly in the panel just before this, the opportunities to infuse those rapidly advancing non-aerospace sector technologies, you know, the communication, information, networking technologies, the automation is one. I think, you know, another that to me doesn't necessarily get as much recognition, but the innovation in the energy sector. If you look at the number of patents that are being let in that sector, they're rapidly accelerating. So how can we take advantage of things going on in the energy sector as we look at challenges in aeronautics as well? So last year at this event, we had the good fortune of having the NASA administrator, Charlie Bolden, stand up and actually give a keynote speech on the new strategy, and subsequently We had a couple of articles in the subsequent Av Week that really both picked up the themes that we had in terms of the fact that we're in good shape as an industry, as an R&D enterprise, but we're facing these issues, and the fact that we really do need to take on this new strategy as we look to the future. So that's a lot of the why behind why we're going down this path. And if you were at the 8 o'clock session, you saw this chart that Jaewon put up. I'll spend a couple more minutes on it just to give you a sense of why we constructed it this way and what it means. So you see that the innermost circle that indicates global, and it's the kind of things we're doing today in safety, in next gen, in efficiency and environment that really are those core sustaining research elements and technologies that we need to perform against to really meet the global growth that's going to occur for aviation. Aviation is rapidly rising, especially outside the boundaries of the US and Europe and Asia Pacific and so forth. Tremendous growth. That growth wants to be supported, and the industry wants to take advantage of that. And of course, that's part of the growth in the middle class, the growth in megacities across the world. That's why that growth is occurring. But we've got to add that sustainability component to it if we're really going to be able to realize that growth. And of course, part of that is the low carbon challenge and the kind of commitments that the industry have made to achieve not only sustainable growth in aviation come about 2020, but actually to turn the corner and reduce overall carbon emissions. That's a very laudable goal, a very tough goal for the industry to meet, given the level of growth that's going to occur. So a lot needs to be done to support the low carbon. And on the left of that, the intelligence is again this morning at the 8 o'clock session, this idea of affordability came up, and I think part of sustainability is the affordability component. Part of the way we can get to affordability is through adding intelligence, getting to more highly autonomous systems and so forth. And so we need to add those elements of sustainability, new approaches to manufacturing, and those kinds of things become all part of that sustainability package. And finally, there are so many opportunities, at the conference this week, so much discussion around unmanned aircraft and the possibilities there. But that's just what's happening today is just a tip of the iceberg as to what can happen from a transformative perspective. And NASA wants to be at the tip of that sword, trying to put in place the concepts to challenge current conventions and current conceptualizations, and to look at new ways to bring value from aviation into the broader economy. A couple of ways that, again, one that came up this morning was speed. Again, if you look at the globalization component, the rise of megacities across the globe, the rise of the global middle class, if we're connecting these very distributed cities, speed, today aviation is our high-speed mechanism for joining the globe together. And I think if we can overcome the challenges of the boom and other environmental and affordability impacts of supersonics, I think that'll be a very important part of the aviation system. And of course, then on the left side of that chart, this idea of on-demand, the fact that much of our economy is because of the ability to put applications on the fingertips of people to directly access information and services and other things on demand. Part of aviation is going to want to be that as well. And of course, UAS is again the sort of the leading edge of that. But there's no physical, physics-based reason that aviation transportation can't be, have an on-demand component to it as well. So a lot of that can be done in the transformative area, but a lot of research is going to have to be done to make that happen. What we've done is to then say, well, specifically, what do we want to try to accomplish as we look forward, as we look to that vision, and we've developed these 6 thrusts. The first is safe, efficient growth in global operations, and it's our continuing commitment to enable the full vision of next gen. So it's both the commitment to contributing to FAA's current plan and implementations, but it's also our commitment to be laying the groundwork for where next gen goes next, and even to look out beyond next gen, and to continue in that thrust as well, to continue to make sure that we're taking strides to reducing aircraft safety risks, so that as traffic does increase, we don't see an increase in hazards and risks and incidents and accidents. The second one is innovation in commercial supersonic aircraft. Again, this was discussed earlier. We're taking a very stepwise approach to this. The key thing right now is, as Jay explained at 8 o'clock, is there's a prohibition to overland supersonic flight, and that is due to the sonic boom. So the first step we need to take is to see if we can achieve a low boom standard. There's been a lot of work done in analysis and ground tests that shows that the possibility is there, the promise is there to develop aircraft configurations that in fact have a much differently shaped boom with a much lower impact. But a lot of work needs to be done to actually prove out that in fact is the case, and to then do the work to show that boom is an acceptable impact to folks that would be impacted by overflight of a supersonic aircraft. So we want to take that first step, and then we'll see what innovation comes in the commercial sector, and then we'll take next steps as appropriate. A continuing commitment to ultra-efficient commercial vehicles, both fixed and rotary wing. We really want to pioneer those big leaps in efficiency and environmental performance. So we've been going after the efficiency, noise, lower emissions for local air quality and so forth. So a continuing commitment to pioneering those leaps, both the individual technologies as well as the integration and the configurations that go with that. But we wanted to draw special attention, and we created a separate thrust then for transition to low carbon propulsion. If we're really going to turn that corner as we approach mid-century and really drive down the carbon emissions from aviation, we're going to have to find very new technologies and new ways of doing that. Clearly, alternative fuels is at the leading edge of that. Finding those alternative fuels that have low life cycle carbon emissions and doing those as drop-in and blended fuels that the industry can hopefully take advantage of it on an affordable basis. We also want to look at new engine cycles, whether those are hybrid electric or potentially something else. How do we, and again, this is an area where we can take advantage of accelerations in say, the energy industry, in batteries and power electronics and other things, where perhaps we can bring some of those technologies in, we can combine it with what we do well and see if we can't develop new cycles, new engine cycles, or combined cycles and so forth to develop low carbon propulsion technology. This is one of those, to me, this is one of those kind of very significant, once in a 100-year kind of changes that it's going to take a lot of research, a lot of work to create the ability to make a decision to go towards a new type of propulsion. So that's why that's got such special focus there. The last two really playing off this idea of technology convergence, the bringing together of low-cost sensors, low-cost computing, networking, communications, and so forth into our systems to do things that we couldn't do before. One is in real-time system-wide safety assurance. So if you think about big data, you think about analytics and so forth, the ability to bring information from all our systems together, understand where the anomalies lie, how to understand if those anomalies are things, those off-nominals are things that are real risks in the system, or just part of, in the larger sense, the way the system operates on a day-to-day basis and evolves on a day-to-day basis. So it's both taking advantage of that accelerating and converging technology, but it's also taking advantage of our ability to model and understand what all that data means and to take appropriate action based on that understanding. And then finally, assured autonomy for aviation transformation. You know, how do we bring higher levels of automation and autonomy? How do we achieve greater levels of human-machine collaboration to do things very differently in aviation? Bring higher levels of efficiency, bring all new business models, achieve higher levels of safety, and so forth. And I would just a plug. We sponsored a National Academy of Science study on autonomy for civil aviation research needs, and they just delivered the report. If you go to the National Academy's website, you can download that report. They kind of coined a term, IA, or increasingly autonomous systems, to try to get us away from all the challenges with going to the extreme of a fully autonomous system, but recognizing that over the next couple decades, what we're really dealing with is increasing levels of autonomy and the kinds of things we need to deal with in order to address those issues. So those are the 6 thrusts. What we have done over the last year, since Aviation 2013, is looking at, okay, so that's the strategy. How do we organize in order to effectively implement the strategy? And so we had 3 things that we wanted to do. One was clearly to pursue innovative solutions aligned with the strategic thrusts. And so we did some program reorganization, which I'll talk a little bit more about, to essentially make sure that our programs had clear ownership of those thrusts. And so now we have the Airspace Operations and Safety Program, the Advanced Air Vehicles Program, and the Integrated Aviation Safety Program that satisfies that goal, that first goal of pursuing innovative solutions aligned to the strategic thrust. And again, I'll talk a little bit more about those programs, and the programs directors will speak in more detail as well. The second goal is to take this, see what we can do in taking this idea of technology convergence very seriously. So really trying to incentivize this multidisciplinary, innovating at the seams, bringing in new technologies, new perspectives, new cultures into the research process, and making that a truly convergent kind of approach. So we want to create that flexible and organic environment that allows for people to reconceptualize solutions to big challenge that we're facing. So yeah, we have good ideas as to where we need to go and how we need to get there and the research needs that are required, but we ought to be challenging ourselves and looking at new concepts and giving those new concepts a chance to sit at the table and to prove that they're feasible and ought to be pursued as well. So we have a new program, Transformative Aeronautics Concepts Program, and we'll be talking more about that. And then finally, for NASA Aeronautics, we've got 4 world-class research centers across the country, and we want to give them a greater level of workforce institutional agility and flexibility in order to be able to change. As we lay out this strategy, it implies a level of change in where we're putting emphasis, where skills and disciplines and so forth and facilities are needed. And so we need to create some flexibility in order for the system to evolve over the next 5, 10, and 15 years and beyond. So some of the things we're doing is to get the institution closer to the program. So we're embedding flight research more closely into what we're now calling the Integrated Aviation Systems Program, and we'll talk about that, and then our ground test facilities into our Advanced Air Vehicles Program. So, and then we're looking at ways to to enable more agile research practices that bring our people, our analytical abilities, our ground test abilities, and our flight research capabilities all together and work those in a more organic way. So a lot left to be done on goal 3 to really, that's something that we're going to have to work over time. But those are the 3 things we're trying to accomplish, and we've focused our reorganization around that. And so here's the alignment that I was talking about. So Airspace Operations and Safety Program, the 3 thrusts that it's taking, primary ownership of safe, efficient growth and global operations, real-time safety, system-wide safety assurance, and assured autonomy for aviation transformation, and advanced air vehicles, the ultra-efficient commercial vehicles thrust, the innovation in commercial supersonic aircraft, transition to low-carbon propulsion, and right now, a secondary role in assured autonomy for aviation transformation, but we want to put that in there because it's not just about the airspace, it's about the vehicle, how those things come together, and so we need to find ways to make sure that both programs really take that into account. And then the Integrated Aviation Systems Program is really now changing to more heavily flight research-oriented, integrated system-level R&T program that's going to support all of the thrusts, and trying to bring back that spirit of the X-planes and into the mission directorate. But we're going to have to find creative ways to do that. We're going to have to look for creative partnerships in order to make that happen, because it's clearly X-planes are can be resource intensive, and so finding ways to do that creatively is going to be very important, and we'll be talking more about that. And then finally, as I said, we have this new Transformative Aeronautics Concepts program that's going after those high risk, kind of leapfrog ideas, but it's also the place where we are sustaining commitment to technologies and methods at an individual discipline and in a multidiscipline perspective as well, but we need to sustain commitment to the fact that we still need to develop greater levels of understanding on the physics of flight, keep putting that understanding into the methods and models that we can use to both analyze and design vehicles. So a firm commitment there as well. So with that, I'm going to reintroduce the program directors, and then we'll talk in a little bit more detail. So John Cavolowsky is now the director of the Airspace Operations and Safety Program. Jay Dreyer is now the director of, or I guess in a couple months, okay, will be the director of the Advanced Air Vehicles Program at Waggoner, Integrated Aviation Systems, and Doug Rohn, Transformative Aeronautics Concepts. And I've got one chart for each, and I'm going to basically go to that chart, and each program director will speak for about 10 minutes on giving a little bit of insight into what's going on in their program area, their new program area.
Great.
John?
Bob, thank you. So I think Bob did a great job in defining and describing the strategy, and frankly, it was a refresher, if you will, from the strategic perspective of what was rolled out last year. I think to great support from you and your colleagues in the community. Just want to provide one bit of emphasis on what Bob had laid out, is that the strategy was new, direction's exciting. It wasn't put in place, it wasn't established because something was broken. We've been doing, I believe, and I'd like to think that you all share this same belief, that NASA Aeronautics has been providing tremendous capability, products, and insight to the community for a number of years. Similarly, we're going to a new program structure, not because things were broken, not because we had poor program performance before, but because it does provide better alignment with this compelling strategic direction and the thrusts that Bob just spent some time talking about. And in particular, for Airspace Operations and Safety, this structure is allowing our alignment and our ability to support R&D for the inherent integration and interdependence of operations and system-wide safety performance. So as you see in the text here, the Airspace Operations and Safety Program is going to be essentially the ATM research, development, and demonstration elements that have been part of the Airspace Systems program for so many years, but bringing in the inherent system-wide safety elements from the Airspace Systems program, from the Aviation Safety program, and the ability to provide a strong integration and interrelationship of those elements and development of quality products going forward, not just for the operational element, but for the safety element of the overall system. Now, to suggest that Airspace System had not been addressing safety before is wrong. We have been, but the opportunity to bring in some of the advanced capability that has been driven aggressively through the Aviation Safety program over the years is providing far greater additional value and integration of our capabilities. So in order to be able to put that into practice, we are establishing now 3 projects within AOSP, and you see those on the lower left side. So the first project on the list, the Airspace Technology Demonstrations, or as we're referring to as the ATD project, is an activity that is looking to create capability in a shorter term time frame and transition that capability through partnerships for use in the system. Domain efficiency, affordability are key characteristics of the products that we're looking to develop and deliver through Airspace Technology and Demonstration. And frankly, they are aligning extremely well with a time frame associated with the next gen deliverables that our key government partner, the FAA, has been helping to define and drive for a number of years now. Many of you may have heard Ed Bolton talk very passionately about the work and the deliverables, as well as Michael Whitaker from earlier yesterday morning. Our work is in looking to support many of those same thrusts across our areas of domain and capability. We listened, perhaps a number of you listened to Jay Shin's panel with Steve Bradford and other colleagues this morning. A large part of what we are hoping to do in this particular project is accelerate the opportunity to transition our technologies for faster implementation in the system. And I'd like to think that we have an opportunity to reverse that trend of Steve's inverse dog years, transition cycle for getting systems in and capability into the system. It is a challenge. When I get on an airplane, when we all get on airplanes, we don't want to have to worry about whether we're going to make it, about whether there's going to be any additional efficiencies or safety concerns. So we're very happy to take advantage of all that the FAA and their culture of safety has brought to the system. But we also want to be able to try to accelerate the opportunity to bring in new capability and products through the technology, and our ATD project is looking to drive that in this near-term time frame. As you can identify, close alignment with the safe, efficient growth in global operations is where this particular project has the strongest alignment with the thrusts. Okay, so if you look a generation beyond this, if you look towards one where domain efficiency isn't the major thrust or the imperative, but rather system-wide efficiency. Predictability, reliability are inherent characteristics of that future. And frankly, if you talk to our customers and our partners and stakeholders in the airlines, if they're talking affordability first, the next thing that they talk about in terms of their requirements and their needs for the system is in predictability and reliability, their ability to look forward towards developing a business model that's sustainable and that competitiveness within the global market. Predictability is a key element of that. Our second project, the SmartNAS testbed for safe trajectory-based operations, is an effort to look to address some of that. We have a system right now dominated by humans in the system. Humans are providing tremendous elements of safety and mitigation of concerns, but given the structure of the airspace, the multiple handoffs, the sectors, there isn't a single trajectory, if you will, an efficient trajectory and path within the airspace that can help provide that element of repeatability and predictability and reliability of the system. We're looking to develop a trajectory-based operational concept and technologies that will allow that to take place, but we also need to develop a test bed within which to evaluate that. We cannot test it in the system today because of the nature of all those handoffs from multiple waypoints throughout the system. The SmartNAS, which stands for, and I'll give you a quiz on this when we leave, Shadow Mode Assessment of Realistic Technologies for the National Airspace, is a test bed to allow us to put in new architectures, to evaluate new technologies, to bring in elements of prognostics, elements of V&V that the safety program has been driving for a number of years now, to allow us to evaluate this system in ways that it cannot be done in the current NAS as we know it today. That capability looking to bring inherent safety elements, understanding of operational capabilities that would provide that system-wide efficiency, predictability, and reliability. As you can see, perhaps from the names and the description of that work, the Thrust 5 from Bob's briefing on the real-time system-wide safety assurance is where this particular project has the strongest link. No one of these projects are aligned exclusively to those thrust areas, but this is where we have the greatest center of mass and opportunity to deliver. And the third project, you see over the safe autonomous systems operations, is looking to address a future beyond where we are today. If you can imagine the first project ATD, looking at next gen as currently defined. The SmartNAS testbed for safe TBO is addressing a future or a full next gen view, much like the JPDO had defined back in early 2000 with real system-wide trajectory-based operations. This third project is looking at a future that is frankly beyond the next gen view, elements of much more highly autonomous operations to provide this inherent scalability, flexibility, and resilience that system needs to provide. SASO, the Safe Autonomous Systems Operations Project, is addressing those elements. What is an architecture that can look to take advantage of the greatest beneficial amount of autonomous behavior in the system and operation in the system that allow that kind of benefit for affordability, but also that scalability and flexibility that will have to respond to the new and emerging aircraft and systems and business models that autonomy can provide. You heard perhaps yesterday some of you sitting in on that panel on the next billion-dollar industry and UTM, the UAS traffic management. In this particular project, we're looking to drive the early definition and early builds within that. We are looking to establish this architecture for what we call AutoMax, the maximum opportunity for the system to behave in much more autonomous operational capabilities. And we're also looking at some other thoughts in terms of things like single pilot operations, which have, again, the ability to contribute to this greater scalability and flexibility and affordability of the system. As you can see from that description, the sixth thrust on assured autonomy for aviation transformation is where this largely fits. So I think this is an exciting new program. I think that bringing together the capabilities that we have in the safety program with the operational opportunities and concepts we've been driving on ASP for so many years provides, I think, a solid structure, a strong alignment with the strategy, and an opportunity, again, to bring in the community around helping us define some of these key areas of real-time system-wide safety and assured autonomy around operations. So, thank you.
Thanks, John. Okay. Next is Jay Dreyer.
Okay, well, thank you for the opportunity to talk about the Advanced Air Vehicle Program. You've just heard about the airspace and the operations aspect. The Advanced Air Vehicle Program has the same kind of mission, but with a vehicle focus. And John alluded to the fact, too, that there's not necessarily within his program a strict alignment to each of the thrusts. The same thing holds true here. We have cases where in some cases, projects will cover multiple thrusts and multiple projects also working on a single thrust. So I'll talk through a little bit about what this new structure will look like. And actually, it's not going to be too far from a translation of what you see in the current fundamental aeronautics. And we actually went through a restructuring last year. And so that was a lot of work for us then, but it's really helped us at this point because it's helped us align to what this new structure and in the direction that we're moving out and has helped us in this sense. And so we'll start with the Advanced Air Transport Technology Project. This is what's grown out of what people know today as fixed wing, a large focus in that thrust 3 area that we have in the more efficient vehicles. Clearly, this has been a large area of focus from a NASA perspective on both the efficiency and also the environmental aspects, and really exploring some of those new concepts and things that were alluded to earlier in the 8 o'clock meeting. You know, we're moving beyond that possibility of just having tube and wing aircraft in the airspace. What might some of these new configurations look like? Where are some of those key technical challenges to enable those? And it's not just looking at the vehicle or the airframe or the propulsion, the integration of those units and things like that, areas that this project will continue to push forward on. At the same time, we also talked about that thrust forward, the development of the low carbon technologies. And we're doing some of that work right now, for example, in the alternative fuel areas with the characterization of those fuels. But I think there's a real exciting future in moving beyond some of the traditional propulsion cycles that we have right now. And we're exploring some of those hybrid concepts and things like that that can grow to these larger scale of vehicles where we'll really have a significant impact and make a difference in the future in these areas. So these are our areas that this project is really moving out on. And next you see the revolutionary vertical lift technology project. Clearly vertical lift offers some capabilities that we see today in our airspace, and we take advantage of those capabilities, but we're also looking at how that we can potentially grow new markets, new areas with these type of capabilities. This again lines up to the more efficient vehicles. Clearly there are a number of environmental barriers, things like noise and even emissions and efficiency that comes into play for more widespread use of these vehicles. We're going to look at those type of elements. But this is also an area where we see a lot of international competition, and how can we continue to provide that innovation, that spark, that allows us to continue to grow and succeed in these areas. And while the initial focus in this area is on some of the more traditional areas that we've worked, the efficiency, the noise, and areas like that, it also provides a great growth opportunity for moving into things like the more electric, the hybrid electric propulsion, and also potentially in the future the more autonomous elements, because these type of vehicles clearly would be a prime candidate to take advantage of those type of technologies moving forward. So next you see we've got the high-speed project, also will be known as the Commercial Supersonic Technology Project. And a lot of it, I think, of excitement about this, because this is one of those projects that's really trying to open a new market, an innovative type of technology that we have not seen. And that potential for overland supersonic flight is something that would really make a difference. And we've had some exciting sessions on this earlier in the week, and then it was even discussed again at the session again this morning. One of the things that's made this, that's gotten us to this point is because we've made significant progress on both understanding how to design these vehicles, but also how to understand and measure and the impact on the community. We need to continue this research so we can continue that along that track, the progress that we've made in this area, and that we'll continue to do this in this particular area. The next element that you see is the Advanced Composites project. And so this is getting into an area that I think is a little bit different from where we've had a focus in fundamental aeronautics. We've always talked about sort of performance barriers and how do we make an aircraft that's more efficient or quiet or reducing NOx. But we really haven't touched on things like the affordability, or how do we accelerate the introduction of some of these technologies. And I think this is really a core element that we're going to see in the Advanced Composites project. So right now, that's just being started this year in the Integrated Systems Research program that Ed leads. That will be coming over to the Advanced Air Vehicle program. So we're excited because I think that'll add a new or different dimension to the work that we've been doing so far, and will keep us moving forward. And then we see the fifth project that's listed up here, and we've talked about safety and some of the other elements, and I want to touch on that just a bit. But one thing we haven't talked about so far in the session yet is those capabilities that enable the research to happen. And so when Bob showed that list of programs, one thing that you didn't see up there was our advanced our ATP, or Advanced Technology or Airspace Technology Program. That was handled things like our facilities, our ground test facilities, or our flight test assets. What we've decided to do, and this gets to the third point that Bob mentioned on the drivers of what motivated some of the restructuring that we're doing, we're integrating that in with the research. And so this project that you see here, the Aeronautics Evaluation and Test Capabilities, this is really where you see a bulk of what was the ground test element of that ATP program. So the idea here is to continue with the good things that we've learned from the aeronautics test program, the things like the portfolio management and how do we preserve those capabilities and enhance those capabilities as we move forward. But what we're going to try to do is align those even closer with those research needs that we see going forward, because like sort of the theme that you see around, things are changing. We need to make sure that we hold on to those capabilities that we need to move forward and continue to enhance and build those, but we also need to see what else do we need to develop as we need to move forward and support the research that we're doing here. So that's going to be a critical element that we see in this portfolio. Along with that, John also talked about how safety elements are even infused greater into the operations side. The same thing is true on the vehicles. I would contend that even in fundamental aeronautics, there are safety aspects that we have been addressing as part of our research. We intend to strengthen that significantly and not treat safety as something that another program will take care of when we're looking at some of these advanced configurations, but look at what are some of those long poles, some of those drivers moving forward. Now, let me be clear. The emphasis of what we're doing are on those strategic thrusts that we talked about. So things like the new configurations, the low carbon propulsion. But what are also at the same time, what are the safety elements that we need to be addressing when we're exploring those new capabilities? So the idea here is not just in safety, but I think it's also true of the entire portfolio. How do we continue to have that long-term vision, but along that way make those near-term impacts that we can deliver technologies that we can start having an impact instead of waiting the 10, 15, 20 years that it may take to start seeing things. So I think that really characterizes our outlook. A lot of people have heard us talk about the N+2, the N+3, the second and third generation beyond where we are today. Our emphasis is still going to be in that area, but along that way, we are going to look for those opportunities to transition the technologies, and sometimes they may be to smaller platforms or different areas of the market along the way, as we'll continue to do that. So the other thing that I wanted to talk about, so that gives besides just the general structure of how we're working and things like how we'll bring in the test capability aspect and also the safety, is the idea of taking technical risk. And as we structure these programs, we define specific technical challenges that we're going out. We'll establish research milestones along the way. That does not preclude us, though, from taking technical risk. And I wanted to, at this opportunity as we're moving into the program, I wanted the chance to emphasize that. I think one of our roles as NASA, as a government organization, is to do that, to advance the state of the art. And we do that by trying things that are hard. And sometimes these things won't work out. So even when we set these audacious goals sometimes, if we don't reach them because of a technical matter, because we didn't understand the physics and now we do and we've answered a question, that's knowledge, that's learning, and that's moving forward. That's different from we just didn't have the ability, from a management perspective to get where we want to go. So even though we try to chart our course with these roadmaps, with these milestones, I really want to emphasize we are about taking technical risk in what we do. And so this is both to the NASA workforce, but also to our partners as we step forward. And I see the other thing that this structure, another thing that I wanted to discuss is how this structure will help us work together, amongst it. Clearly the vehicles have to operate within the airspace, and so there's a clear correlation between some of the work that John's program will be working on and what we see in the Advanced Air Vehicle program. And so we'll continue that type of relationship. But I think we've got some new opportunities of how we will work together. For example, how can we set the stage for what some of these exciting potential future flight demonstrations may be that happens within the IASP program that it'll be leading? How can we set the stage, get the seed corn to put that in place? And that'll be an exciting opportunity for us. At the same time, we talked about some of the transformative ideas that are going to come out of the program that Doug is leading, and we'll talk about in a minute. And I think that'll take two forms. One, the new ideas, the concepts. For example, where we might get some of the new ideas for where the right research to focus for NASA in autonomous application within vehicles may come from. But also in some of those core technologies, aspects that are currently in the fundamental aeronautics program in the aeronautical sciences will now become a part of the transformative aeronautics program. We need to maintain that strong connection that we have and develop those capabilities so that we can utilize those and move forward. And the final thing I just wanted to say is, I think these are exciting times. We appreciate the opportunity, but the reason that we're able to sit here today and talk about moving forward the way that we are is because of the hard work that everyone's put into to get here. So I look around, I see a lot of people, a lot of our NASA colleagues sitting in the audience, and folks that are out at the centers that have really made this happen. Because like John alluded to, we're not doing this because we had to, we're doing this because we can. And that's built upon the success that we've achieved from the hard work and the creativity. But it's not just the NASA people. I also look around and I see some of the partners from industry, from other government organizations, or from universities, and we've all made this happen together. So I just wanted to say, my personal appreciation for what we've been able to do over the last few years, and excited to see what we'll be able to do looking forward.
Here, here.
Thanks, Jay. Next up is Ed Waggoner.
Yeah, thanks a lot for this opportunity to talk a bit about a real exciting opportunity we have in Integrated Aviation Systems program. And testament to all of you, I was looking out there, it's 120 or 130 people here on Friday morning, the last day of a 5-day conference. And so it's really gratifying to all of us to be able to give this overview to you. So I'm going to talk a little bit about where we are, the vision of where we're going, and then how we're going to get there over the next few years, and take a few minutes. So integrated systems research, where we are right now, I've often described this as J1's grand experiment. So the hypothesis here was that NASA can put the capabilities, the resources together, and the processes to deliver key technologies against really stretch goals, and do that in a time-constrained environment. And we just got kicked off on our third project within this, but 2 of those projects are poised to deliver incredibly successful technologies over the next couple of years. So Faye Collier right here has put together a team looking at environmentally responsible aviation technologies, looking at airframe technologies, engine technologies, how you marry those together in an integrated sense. And the men and women that he's put together are poised to deliver on 8 integrated technology demonstrations next year at the end of that project, when we promised 6 years ago that we were, well, 5 years ago now, it'll be 6 years. 6 years next year that we promised that we were going to deliver, and we'll be successful on every one of those. And so that's a testament to the dedicated folks that are doing this work at all 4 aeronautics centers, as well as a new way of doing business and the cultural change that comes with that. That was followed on the heels of the second project that we had in integrated systems research, the integration of unmanned aircraft into the NAS and routine access. They are now they've finished their first phase of that work, successfully completed the key decision point, allowing them to enter into the second phase, have baselined the work that will be in the second phase, focused on key technologies that the FAA has recognized as incredibly important for routine access, and will be delivering validated research results from integrated human-in-the-loop simulations and 3 flight test campaigns as part of that work by the end of 2016 to the RTCA Special Committee 228 that are developing the minimum operational performance standards for unmanned aircraft against detect and avoid and command and control issues associated with that. So highly successful. We just got kicked off with the advanced composites project, looking at reducing the time to certify advanced composite materials. We've got through formulation. We've got through the non-advocate review of an innovative partnership philosophy that will be employed there. And so we're ready at the end of this year to hand this over to Jay Dreyer and his new program for the last 4 years of that effort. So the question could be, so you're stepping away from this? No, we're not. From Jay's experiment and proving this hypothesis that we can do that, that same philosophy is going to be integrated into all of the programs that you see up here. And so that we can deliver and retire these technical challenges in a way that uses the resources, focuses those resources, and delivers products in a timely manner. Now, the exciting thing, though, that we have in the new part of our structure in integrated aviation systems has to do with this renewed flight emphasis. And so we're looking at that in two aspects. So part of that is the capability that we're inheriting from the ATP program, from our test capabilities, and it's the flight aspects of that. So the capabilities for ranges, the test aircraft and support aircraft that we have, the simulation capabilities, and the loads lab that we have out at Armstrong. So we will be inheriting those capabilities. We'll be the stewards of those capabilities, and we're doing right now kind of what I call due diligence, looking at those assets, assessing those, evaluating where the opportunities are to right-size all of those capabilities that we have. We're also going to be taking on what we call smaller flight demonstration projects. And so all of this is under an umbrella that we call flight demonstrations and capabilities. I talked about the capabilities, but we're also going to take on flight demonstrations that we look at as somewhat complex. So they could be complex because we'd be using multiple assets at one time, similar to what we're doing in the UAS and the NAS project with our live virtual constructed distributed environment, where we have live aircraft, where we have virtual aircraft, we have simulated traffic, all working together in a seamless way. Maybe complex sensor integration into an aircraft that requires some real key technologies and capabilities that we would bring to bear there. It could be very high focus, just a complex environment that we would be testing in. And so all of these would be attributes of the types of demonstrations that we would have in IASP. But that's not the only flight work that's going to go on in the Mission Directorate. There could be flight work in any of these programs at any TRL level at any time. And so they will draw from the capabilities that we have. J1 has coined a term they call the Uber Integrator, where we'll look at in-house capabilities. A lot of this resides at Armstrong, but also at other centers. We'll rely on that, bring that to bear on these flight demonstrations, regardless of whether they're in IASP or any of the other Mission Directorate programs. So it's exciting for us to look at this. And what we're doing right now, we're doing our assessment, we're doing looking at the capabilities that we have, we're looking at what's going to be needed, and then making sure that we're down a path that's sustainable, that looks at the vision of where we're going in the future, and make sure that the capabilities and the direction that we're going matches up together. And I've talked a lot about what we're doing just from within NASA, but we're also going to broaden the aperture. We're going to look at the kind of capabilities that are outside of NASA as well. We're going to learn from those. The things Faye and his team are flying an experiment on the Boeing Eco Demonstrator. And so this is something where regularly scheduled flight demonstrations of key technologies are taking place. Schedule-driven, you've got to meet these gates. And so we're looking at that as maybe a way that we can exploit the way that Boeing is doing that and bring some of those capability or bring some of that knowledge in-house and use that relative to the things that we're doing. So we're opening the aperture there. So we're really excited. We're going to see the end of ERA next year. We'll finish up our UAS and the NAS project in 2015 as we're bringing on this new way of looking at flight, integrating those capabilities in the Mission Directorate, and it's a really exciting time for us, not only in what we're finishing, but now poised to take on some new challenges and a new way of doing business relative to flight demonstrations.
Thanks, Ed. And last but not least, Doug Rohn with the Transformative Aeronautics Concept Program.
Okay, thank you. Thank you, Bob. And I, too, thank you all for being here and giving us the opportunity to speak to you this morning. And on the subject of thanks, I thank my fellow PDs for allowing me to go last, because I was just sitting here thinking that this morning we mentioned that this conference was in the backdrop of the World Cup soccer. Well, Atlanta's still a baseball town, so I'm batting cleanup. So, thank you, thank you. Now I'll leave it to the audience to determine whether we've cleared the bases or done the opposite. So, So to talk about the Transformative Aeronautics Concepts Program, it's a mouthful for me, so often we just say TAC. In Bob's earlier chart, he showed one of the goals to create an environment where we can be flexible and provide the environment for doing new, convergent, multidisciplinary things. So I want to focus, or I want to keep that in mind as we talk about what the actual content of the program will be. We also mentioned that the name of this session is Why a Strategy, but yet we're talking more about maybe the approach and some of the details. Well, I'm gonna kind of couple those two together because I have less to talk about the specific technical content and more about the approach and how that matches kind of why the new strategy is happening. So kind of three things that I think about in Transformative Aeronautics Concepts. One is that we're looking at tomorrow's, or we want to encourage that flexibility to look at high-risk tomorrow's aviation concepts. We want to focus on looking forward. Second, I think in terms of making investments, we call it a seedling program. We want to cultivate ideas. We want to encourage, make investments along the way so that those ideas can grow. And then third, kind of the approach is let's make sure that we are asking the right questions, the big questions, setting the stage for answers that will create those next capabilities. So within the program, we've got it lists here 4 projects. There's really 3, but the first project, cross-program operations, is just a way that we at NASA headquarters deal with some funding that we need to provide for some operational activities. So I'm going to talk about the other 3 projects, and I'm not going to do it in the order maybe that's on the slides here. First, I want to talk about Convergent, the last one, Convergent Aeronautics Solutions, or CAS for short. Here the overall objective is indeed to provide the incentive and the environment for convergent, multidisciplinary, bringing things in. It's a new project, a new idea. It too is an experiment. It's an experiment in the way that we at NASA set things up. Not everyone within either our partners or within our own in-house workforce would want to work in this mode, but many do. And the focus is on showing feasibility. Whether that's rapid prototyping, whether it's small-scale flight tests, whether it's analysis, but the focus is on, in the Convergent Aeronautics Solutions, is to identify what those possible solutions are, take a look at harnessing convergence, and then the idea of fail early, fail often. Let's give them a shot. Let's have fast turnover so that the success of the project is not that we proved a certain dB noise reduction or that we proved a certain level of emissions or whatever. The success of the project is that we worked on it and we developed the knowledge so that the feasibility is either shown or not shown, and then that knowledge then can be transferred into either one of the other programs or out into the field. The next project I want to mention is the one that's on the slide there, the Leading Edge Aeronautics Research for NASA, or LEARN for short. We've had within NASA Aeronautics for the last several years a seedling activity. LEARN was part of it. LEARN was an outreach to the community, a way to involve, encourage, challenge, and excite the outside of our walls, beyond our centers, beyond our folks. Uses similar concepts as I was just mentioning for CAS. It looks at investments, looks at big questions. What are the challenges? What are the feasibility questions that we need to answer? And as I mentioned, it's been it's been both in-house and out-house, but the Learn project is a solely external focus, providing the opportunity NASA funds, looking possibly for leveraging, but working with those in the community to look at challenges and prizes even, but look at knocking over challenges. And both CAS and Learn, I would say, are about challenging the challenges. Some of the programs, the other programs have technical challenges, technical barriers set up. Well, we want to determine what are the new barriers. If it's a feasible thing, what's that new barrier that then I can hand off to either the community or to my peers here to knock over that challenge. And then the last project that I want to talk about, besides reorganizing, we like to change names. So I have a new name even than what's on the slide. There it says
control got me.
Revolutionary.
Yeah. I forgot to change the name.
It says Revolutionary Tools and Methods. We've kind of adjusted the title of that to be Transformational Tools and Technologies. Not that we love buzzwords, but we want to focus on, we do want to focus on revolution. We do want to focus on transformation, but it is indeed tools and technologies. Bob mentioned the idea of some single discipline technologies. We want to make sure that the NASA leadership and the looking at what's the next thing we really need, similar to challenging the challenges. What's the next big technology that will get us down the road? Also tools, thinking CFD, thinking MDAO, thinking other more computational-like tools. What are the future revolutions? What are the new tools that we need? Not just the make our current tools better, but what are the new ones that we need in order to support some of the breakthroughs that are coming? This particular project is somewhat, in terms of organizationally, it's inherited from the current Jay Dreyer's Fundamental Aeronautics program. Currently, many of you in the audience have been involved, actually at this conference, know it as Aerosciences. We've moved that into the TAC program. They've been on a path of creating this kind of revolutionary, what's the new tools, what are the things that we need to get down the road. They're already on that path, so I'm happy to have it in the program and pick that up and keep it moving so that we are in that transformative support role. So I guess the bottom line that I'd like to say is that we call it seedling. You know, there's an analogy to that world, you know, cultivation. We're cultivating ideas. It is a seedling program to cultivate and encourage and nourish those ideas for the future. Thank you.
Okay, thank you, Doug. Okay, that's the presentation. I'm going to put this back, I think, on on this slide, just so you know, as a reminder of what the new programs are. I'll start off the questioning and encourage people to go to the mic. I'll ask questions as long as there's no one there, but if someone shows up, I'll turn it over to the audience. So the first question, it really sort of came to mind when this week, as I was attending, various sessions and so forth, a lot on UAS and the excitement there and so forth, and we are making a major contribution right now, as Ed said, through the UAS the NAS project. That project is both developing some new capability in form of the live virtual constructive distributed environment that we're developing so that we can actually put in place a relevant environment to test UAS and get relevant data that we can use to deliver to FAA and RTCE so that they can support standards making and so forth. And at the same time, we're also developing a lot of in-depth working relationships with the community and so forth. So that project's slated to end in 2016. And how are we going to take the next steps there? What are we going to sustain that capability? What are we going to do there? So I kind of, to Ed and John, to address that.
Yeah, well, let me start, John, and then we'll hand it over to you. So just to give you a sense of what this is, I alluded to it. So think of this. Think of that you've got a flight test campaign. You're actually flying an unmanned aircraft at one of the FAA's test sites. You've got some virtual traffic that you're doing down in a lab at Langley. You've got another live actual aircraft that you're flying at Armstrong, and you're pulling all of this together at integrating that into a simulation of the NAS that you're doing at Ames. And you're doing that where it looks like that all of these are flying in the same airspace. So that's a live, virtual, constructed, distributed environment, and running your experiment like that. So this is, we didn't conjure up this, but we are developing an environment like this. And we'll be using that, and I'd mentioned integrated human-in-the-loop simulation in 3 flight test campaigns over the next couple of years. As we finish up developing that, then the question is, so what's it going to take as far as care and feeding to maintain that, and how are you going to utilize that? So the jury is still out. We're doing this assessment of what it's really going to take, but we know that there's going to be, we can take advantage of that. And so whether this work ends up residing in IASP, whether it transitions over to John and some of the airspace work, it's kind of inconsequential. That's not important. It's just that we're going to have an asset that will be not only be able to be used by NASA and our researchers, but others as well, to provide a very safe environment to do experiments that are not always the easiest thing to perform and can be rather tough from a safety point of view. So that's kind of the background on what it is, what we're developing, and we are poised to be utilizing this in the flight test, the work in UAS and the NAS. And I think that John has some ideas about using that as well in some of the research that they're doing.
Yes. So as I spoke to the second project in AOSP, referred to shortly as SmartNAS, the capabilities that Ed and his team have been developing, and the community have been developing. Ed and his team have very wisely leveraged a tremendous amount of work that's being done by other government partners as well in order to bring that to fruition, the live virtual constructed distributed environment. That needs to be a foundational piece of what the SmartNAS effort has to be. Whether it be from an unmanned aerial system perspective, or whether that be from an advanced autonomous operation concept or even a TBO concept. We do not have the capability right now to test those for reasons of safety and operational performance live in the system. If we do not bring in the kind of capability that Ed talked about, merge that not just with new vehicles but new operational procedures, we will not be able to advance beyond the state that we have right now. So I see this as being an inherent capability that, again, as Ed pointed out, whether that is going to be housed exclusively in AOSP or not, it is something that we're going to have to manage, we're going to have to leverage, we're going to have to develop within this larger simulation environment for operational concepts and for vehicles. So very excited about what Ed and his team have been doing, and looking forward to that being a part of what we do going forward. Other point I guess I want to bring up, since in the Safe Autonomous Systems Operations project element, we are looking at not just architectures for broad autonomy capabilities to bring to future systems, but also individual elements such as the UTM and small UAS systems at low altitude. The team that Ed has cultivated in his project UAS and the NAS is a team and a NASA capability that we are looking forward to having apply their talents to what we're doing in SASO. How we manage that going forward is all part of the planning and the collaborative work we do, but tremendous capability that is being developed across programs that we're looking now to provide towards our future endeavors.
Thanks, John. Jay, a question for you. So several years ago, the program and what was the fixed wing project did a series of excellent studies, the N+3 system studies and vehicle concept studies that were done. A lot of attention, a lot of good press and collaboration around those things. How is what we've learned from that being translated into the new portfolio? And are there additional studies, collaborations, efforts like that being planned for the future?
Okay, no. And like you said, I think that was definitely a very exciting thing that we did with the N+3 type of study. A lot of it energized the community. We saw a great response from externally from industry, but also from the university community as well. And I think what some people may also lose sight of in some of that, a lot of that also happened internally within NASA that paralleled those external studies as well. So in essence, I think it also helps sort of typify where we're going here. I mean, we're asking the big questions of how can we get to these tremendously tough metrics in terms of efficiency or environmental performance in certain areas, and opened up for new ideas and allowed the innovation to come forward from that. And we saw that happen. And I think what's exciting is we've progressed from the studies to actually starting to address those long pulls. And so what you see happening now within the portfolio are the actual experiments. We have hardware in the wind tunnel that's now looking at things like the D8 configurations, the truss brace wing, and actually, in essence, following through on our promise that said this was a two-phase thing. Let's look at the concepts, and then let's try to start to do something about it. I think it also shows how, even looking back, how our portfolios have evolved. We've underwent a major restructuring in 2006 and lined things up. We're doing a lot of work today that wasn't even on the radar screen back then, and I think some of that, for example, was motivated by the kind of things that we saw out of this. So personally, it's exciting, when I get the call from Ruben or from Rich that says, look, we've just done this in the wind tunnel, look how well it's working. I mean, that's exciting, and I think that's a testament, to everybody working together to see that happen. So have we shown that kind of concept works? I think we have, and we've seen evidence of other people, for example, some of our partners in the DoD, using that same kind of practice, looking at things. We also did it on the high speed, on the supersonic side as well, and I think our N+3 study there helped give, the promise that yes, these larger vehicles are indeed possible. We complemented that, not in a phase 1, phase 2 in the N+3, but we used a separate N+2 type of more validation study that's more akin to what we're doing now in fixed wing, to look at some of these concepts in the small airliner size that's given us the confidence to move forward in this area, that that these vehicles will indeed grow. So I think that concept has worked out quite well. We're definitely looking at potentially how we can apply that in other areas, in other vehicle classes. Potentially could we look at this, for example, in vertical lift, for example. I think the other thing that we've done more recently has shown that sort of this concept of looking at that big question, that study, and looking with that future focus. We've seen that in the CFD 2030 type of effort. We had a good session on that on Monday afternoon where we talked about it, but even looking at a more foundational level for the tools and technologies. And I think what we've learned and some of the ideas that have come out of that are going to help feed into the effort, going forward that Doug will be working with too. So I think a good example of, across the spectrum where we've used sort of that practice. And so I would definitely think it's something we'll move forward with.
Thanks, Jay. A question from the audience. Just identify yourself.
Sure. Hi. My name is Anjaney Kadapali. I'm with Lockheed Martin. And I was curious to know if the National Aeronautics Research and Development Plan put out by the White House OSTP a few years ago, if that played a role in how you've restructured your organization. I know Jay pointed out the fundamental aeronautics program went through a reorganization recently. I was just wondering if some of those metrics in the NARD plan were used in setting goals for each of the individual mission programs.
Ed, if you want to go ahead.
Yeah, I can start with that. So Faye Collier sit right in front of you here. We were just talking about this at dinner Tuesday or Wednesday night. So that's fundamental. He's got three key goals that he is addressing. 50% reduction in fuel burn, looking at a 42 decibel reduction in stage 4 noise, 70% reduction in NOx for landing and takeoff. All of those are right in out of the objectives in the National R&D Plan. That's where they came from. Those have been our guiding principles. Those have been the principles that we make decisions against, used for monitoring and controlling that project. So that's just one great example, I think.
Yeah, and I would say you'd see similar things that we see going forward with some of the long-term goals and where we've lined up the technical challenges that apply in the Advanced Air Vehicle program, which is similar to what Ed's also said. But I think it's also, you know, that the plan should be organic and grow as well. So I think, likewise, I think some of the things that we've learned and discovered in moving forward here, likewise, will inform future versions of that plan as well. So I think there's really two paths that apply there.
And from the aerospace side, the plan did not provide the same kind of metrics that Ed and Faye have been stepping up to. But certainly that is a foundational document that we measure ourselves against in terms of the alignment with the intended area of research and development and advancement that come from that. So it's behind all of what we do.
I would just add as well that a feature of the plan is the fact that it's developed by a multi-agency committee, and I think one of the intangibles, I guess, is that, you know, you get that coordination among agencies. So a lot of what, you know, ends up in the strategy is based on the knowledge and the confidence that what other agencies are bringing to the table is going to be supported and come to fruition and so forth. So.
If I may ask one quick follow-up. As Jay pointed out, some of the things you learned in 2000, or you were planning for in 2006, or sorry, some of the things that weren't even on the radar in 2006 are now, you know, in the radar. People are looking at them. Is there a schedule for updating the plan in the future? It's now almost 3 or 4 years old, and we've learned a lot since then. So I'm wondering, is there a plan to update it? And if so, do you have any insight into that?
Yeah, I won't give a specific date or time frame. But I mean, we're involved in, like Bob referenced, you know, this is something that's not just NASA-driven. Of course, you know, it's in concert with other federal agencies and, of course, the Office OSTP. So we're currently working to try to understand what's the right time frame, what's the right. So we're definitely working on it right now, but I couldn't give you a specific as far as when that will happen. But that's definitely a topic of discussion.
Thank you very much.
Good morning. My name is Justin Kaiser, and I'm a PhD student from Georgia Tech. And first off, I wanted to thank the panel for sharing the strategy and insight with us this morning. I believe this was touched on a little bit, but many of the programs mentioned share similar objectives or technical goals, such as efficiency improvements and emissions reduction, technology development, UAS and the NAS, and tool and methodology development. So I was hoping that you could speak perhaps maybe a little more explicitly on some of the synergistic efforts that will occur between programs and how lessons learned or tools developed from a particular project, completed project, in one program will transfer to others.
So I can kick off. Part of what I spoke just a few minutes ago in terms of the LVC-DE environment that Ed has been developing through his project UAS integration in the NAS. An example of things that we're looking to leverage, inherit, and pull into things that are critical to the airspace operations from UAS and mixed fleet perspective. So, you know, we're clearly addressing those sorts of things. From another program in a relationship, as we look at developing the SmartNAS tool, not only will that capability be looking at operations, it's going to be looking at environmental performance. Some of the capabilities that Jay and his team have been developing for a number of years, the ANOP tool for noise, elements of emissions associated with contrail development and the like, are also capabilities that we're looking to bring into our modeling. So we've got a variety of examples like this, you know, from the vehicle side or the different fleet or operational procedure side that has a home in AOSP, and I'm sure there are other examples. Yeah,
so I would give one, you know, on a more vehicle-related aspect, but say working what seems to be a similar technology, and I'll just use a current example of something that we've done fairly recently with Open Rotor. It was a lot of work done within the ERA project that was under Ed's program in ISRP. So a lot of focus on the testing, understand some of the new technologies there. What fundamental aeronautics worked side by side with them to understand some of the modeling aspects and what can we do for the tool development perspective to advance that technology. So in essence, you had two projects working side by side to develop this. So it involved that kind of coordination of which project is best to manage, a certain element of the portfolio. But we've also seen examples as ERA has matured, where they've gone forward with some technologies. Some also have not moved forward because it's just not ready to bring up to a higher maturation level, where we've taken that back on in a fundamental aeronautics aspect hey, this is promising, we need to continue to work this, but it needs to be done at a lower level, and so we'll manage that within the project that's best suited to do that. And I think what you'll see is, even moving forward, is that stronger connection amongst projects and even amongst the programs, and even amongst the program directors. It's like Ed kind of alluded to, it's kind of immaterial necessarily sometimes which program it necessarily is. It's how do we best coordinate to get the job done. And and there's some cases where you could make a case that it could be in either program. We'll sit down and decide, this is just the best way to move forward, because it's in the best interest of, of NASA and the country, not which program it's in per se.
Yeah, so go ahead.
Go ahead.
I just wanted, because I wanted you to go last, and I wanted that cleanup again, but I did want to kind of leverage on what Jay said, because during phase one, I alluded to this, phase one in ERA, we cast a very wide net. We looked at a lot of technologies, and we had a very structured process to assess where where the most bang for the buck was relative to benefit, cost, and risk of everything that we looked at in phase one. And so we were looking at dozens, 2-3 dozen technologies, and we honed those down to 8. So what happened to those other technologies? Well, some of those went back and were put in the hopper relative to the work that Jay was doing, and he assessed those for additional maturation. Other things we said, they're just not ready for that other work. So I think that's a good specific example. But a more general example, I think, comes from the experiment. So the experiment really has to do, in essence, can NASA's research operate at the speed of business? So can you operate like industry operates? Looking at those key milestones, keep those in the forefront of your mind all the time, and make decisions relative to those. So when you look at the simple-minded way of thinking about project management, you plan it, you staff it, you get the resources, you execute, but then you monitor and control. And that's what ISRP, I think, has brought to the table. And the other programs are going to learn from that as we go forward. The process is needed from NASA's way to monitor and control and technology development, but how we're going to bring those, how we're bringing those to bear. Change in schedule management, risk management, how we do the planning, and bigger than all of that, the cultural change in the folks that are involved in this, the men and women that are working for FAA, working for Laurie Grindle and UAS and the NAS. They understand the time-critical nature of decision-making and the work that they're doing. And so this is a cultural change that's going to be inculcated through the other programs throughout the Mission Directorate.
And the comment I was going to make is a more general. I don't have so much specifics, but two areas, at least from kind of the seedling point of view. One is in the tools and technologies area. Obviously, there are tools and there are technologies that need to be developed for that next revolution that these guys are going to work on, that will be developed. So we will work together there, and we are doing that. And then secondly, in terms of planting those seeds, what seeds do we plant? That has to be something, and it will be something that really the 5 of us, Bob's strategic analysis group and the 4 program directors, we're going to have to work together to define what are those big questions that'll get us the, that next transformation.
Thank you very much.
Got a question here from someone watching the stream online. So,
Cool.
what about different types of fuel and different forms of propulsion? How is NASA getting along on that, or what are their plans of implementation on that in future designs?
Okay.
Jay, you want to?
Yeah, I think that one sounds like it's coming to me. So, I'll start with the alternative fuel aspect, and let me say just up front, our program is not about developing new types of fuel. So I'll say that But what we are looking at is how can that fuel be used safely? Can we understand, the performance, and that will help then others to assess the benefits of those fuels. So I kind of alluded to a little bit, we're doing characterization experiments. And so again, it's not a NASA-developed fuel, but we're testing these fuels. And at first we started off in a ground test campaign, and we've taken that now to flight in a 2-phase campaign. We just wrapped up the second phase just a month ago. And so where NASA will get involved is, how can we measure these emissions in flight, in the relevant environment? How can we produce that scientific data that others can leverage and use? And that's also been a good example of how we've developed that in not just NASA, but also working with others. If you look at when we first started doing those ground test experiments, one of the big images they would show was the picture of the DC-8 and then all the vans from the various organizations, whether it was the EPA, the FAA, or the DoD, or the commercial companies or even universities that were partaking in and contributing to that experiment, collecting the data that various groups would use. So there's elements where we've cooperated together to do that. Even with the latest flight campaign, the Germans brought their aircraft, and the Canadians also brought a research aircraft to assist in the sampling. So again, how do we work with others to benefit, for the benefit of that knowledge? And that also moves to that level, sort of going back to the question on the National Aeronautics Plan. We work with a lot of other federal stakeholders in this manner. So when I say we don't develop the new fuels, but the DOE and the USDA, they definitely are involved in that. So how do we work together so that we understand what they're doing can then eventually feed into the type of systems that we expect to operate in the future, and how do we work together? And so you're seeing a much closer synergistic coordination amongst all of those areas in the entire spectrum as it is to develop the new fuels. So we play, I would describe it as a relatively small part in that whole big picture when you look at it, but it's an important part. And definitely from a coordination perspective, I would argue NASA's one that's helped bring that community even closer together to work together. And that's even extended to working with the community. We've done some good sessions last year of bringing in people from various, the producers, the users, and understand how we can move forward more efficiently, more effectively when it comes to alternative fuels. Now, the other part of the question, what are we doing to look at some of these new propulsion cycles? This was an example of something that really started to come to light, I think, out of those N+3s, those advanced vehicle studies of some of the concepts, the hybrid concepts. That is still a relatively small aspect of our portfolio, but is definitely growing. And so we're looking at where's the right NASA role. We're not trying to solve the entire problem. But we're also looking where can we leverage the right partnerships to make that happen, and where is it right to put the NASA expertise and develop it. So I would argue this is an exciting area of growth for us to look at where the possibilities are, and we're really just getting started, the way I would describe it. But it's an exciting future when it comes to some of these alternative propulsion concepts.
Thanks, Jay. Mr. Ballard.
My name is David Ballard. I'm from GRA, and I have what turns out to be something of a follow-up question or comment. The transition to low-carbon propulsion is usually presented as an environmentally motivated activity. But at the same time, aviation, and I may be struck down by lightning for saying this, is a relatively small piece of the economy and a relatively small piece of the production of carbon overall. And it's probably also a high mitigation cost sector in terms of reducing carbon production. So I wonder if it would be equally useful or compelling to present this transition as something of a hedge to assure continued access to propulsion in the industry as the rest of the economy transitions away from high carbon and particularly high petroleum-based fuels.
So there was a session yesterday where I think something like that came up. The fact that if the rest of the economy is transitioning to different energy sources and so forth, what does that do to the price and availability of fuels for aviation? So I do think that is certainly an aspect of analysis and consideration that we haven't really fully looked at yet. I think the other perspective is that. Two other perspectives. One is that there's an industry commitment, right, to be a good global citizen and so forth, and to and to get to sustainability and to reduce the level of carbon. So from a NASA perspective, what are the technologies that allow the industry to meet those kind of goals? The other thing I think is as you say, as the economy transitions and presumably the overall carbon intensity of other sectors declines considerably, while we're a small contributor today, we don't want to be the thing that sticks out at mid-century, right? So I think all sectors are going to be expected at some level to follow that same reduction in carbon intensity as we look forward. So aviation may have a few more years to work it because we're a small piece today, but by mid-century it may be a different picture.
Yeah. And to follow on, I mean, to what you were just saying about, I mean, when you look at it, and I don't know the exact number, and it's probably debatable, but I think some would argue it's probably less than 5% would be, aviation's contribution to carbon emissions. But even with that relatively low number, look at the attention that it does receive, throughout the world. So even at a small level, we're receiving that kind of pressure. And that goes back to your point on, on the environmental aspect to it. There are multiple dimensions to it. I mean, you could look at it one way from a hedge. On the other hand, when you look globally too about the consumption, petroleum-based products are also growing in many parts of the world as those economies continue to grow and accelerate as well. So a demand for refined products, especially in face of, the growth that could be predicted for aviation, is something else that you have to consider. And so there's multiple reasons I think that could ultimately impact.
Yeah, there are a lot of moving parts, and I was thinking that perhaps in the farther future, there would be less availability of carbon-based fuels in general because so much of the demand would be for low-carbon fuels, which would leave aviation in a bit of a spot if it hadn't made the transition as well.
Right, and that's why I say I don't think there's been much resistance for us moving in this area. I mean, a lot of people recognize the benefits.
Well, let me, I tell you what, I'm going to get a question down here to Doug. So your program is bringing, I think, a very important new perspective, a direct focus on convergence or reconceptualization of solutions and so forth. I know that Doug, you've gone around to the centers now and talked to folks. What's the reception been, and are there some ideas percolating right now? And are people thinking? Are they anxious to put some proposals in? I mean, what's it look like? I know it's early, but...
Okay, yes, thanks, Bob. I have been going around, we all have been going around to our own centers, but talking specifically about this, and the one thing that comes to mind immediately is one of the center directors told me that if we don't do this, there will be people that will leave his center because they're just itching to have this kind of an opportunity. And what I mean, what he meant, and what I mean by this kind of opportunity is the ability to think, think outside the box. I mean, to pull those other technologies in, to take the skills that they have and apply them in a new way that they haven't thought of yet, and do it faster. So all those things are coming together. From the outside, the skills we have, let's do it fast like industry does, like Silicon Valley does, turns things over. So the response has been strong. Some of the ideas that have been kicked around through this conference, there's been several sessions, and John mentioned it about UTM, the being able to do traffic management of UAS at a low altitude. There's multiple ideas of building on that concept. What automation applications? How do we do things that would help that process? So there's been some ideas on that. There's been multiple ideas on merging autonomy, more electric, learn at the kind of the small aircraft level so that we can ultimately scale it up to the larger level. We've had other ideas about how do we do, and I'm talking in the terms of this big question, or asking the right question. How do we do flight test? Ed here wants to be able to have that environment of kind of the X-plane culture, but it's expensive. So there's some ideas. How do we do testing more cheaply, but still take it to that realistic world of flight. So
Good.
plenty of ideas.
Yeah, good. So, Ed, speaking of flight and relevant environments and things like that, so, you know, we have our world-class flight research facility at Armstrong. You mentioned during your talk that while, and correct me if I kind of get this, don't characterize this right, it's sort of a center of gravity, but you're opening the aperture, looking more broadly. You use the example of the Boeing Eco Demonstrator and so forth. How are you going to manage that? Do you have a sense of what the process is for opening that aperture and bringing people in and evaluating what's viable and what's not?
So it's going to be an explicit process as opposed to what I would characterize now as kind of an implicit process, the way that we've done that. Because it's not like that everything is done with NASA, everything's done just with NASA assets. But so we're going to have, it's not going to be a competition, but we're going to request proposals for smaller flight demonstrations. And with those, we're going to ask those proposers to make sure that they assess assets that are most appropriate for the work that needs to be done, that they need to do. And then we'll bring those in, look across the capabilities that we have, look across the available resources, and make those decisions. So just examples of those kinds of things that we have ongoing right now. So out of these 8 integrated technology demonstrations, by the way, that Faye Collier will be delivering and his team will be delivering, 3 of those are flights. So there are flight campaigns. So one of those where we're looking at a very innovative concept for trailing edges, flaps, and how those would be actuated and how those could be integrated from a low noise environment. It's going to be done at Dryden. The concept comes from industry. But then there's another concept on an active flow control vertical tail that's gone from computational analysis, small scale ground-based wind tunnels, full scale, taking a 757 tail, putting it in our national full scale facility, testing that, and now that's going to be integrated onto a 757 actually flown as part of the Eco Demonstrator. So there we'll be working very closely with industry, using industry's assets, their flight assets, and the way that they run their flight tests. And then Doug, in his safety program, he's got his high ash water content campaign where he's actually partnering internationally. And so that's going to be part of it too. So we don't have all of the processes nailed down, but it will be an explicit decision that we will make looking at the capabilities in-house and out-of-house, who we partner with, how we partner with them, and so we're really excited about that. And bringing that new focus on flight research and kind of re-energizing our workforce and our partners relative to the kind of flight research that we can do in the Mission Directorate.
Thanks, Ed.
Virginia Stouffer, LMI. Kind of a follow-on question to the one that you were just answering. Traditionally, there's been a problem balancing the budget for maintaining the ATP assets. There's been various schemes to try and bill for their use versus taking the maintenance off budget, things like that. A lot of different efforts have been tried over the years. It sounds now like the ATP assets are being moved into John's program. How are you planning to take care of those assets? What sort of scheme have you come up with for maintaining and using the ATP assets?
You want to start?
Yeah, I'll start, because actually with the ATP assets, the ground tests are moving within my program, the flight assets and some of the associated capabilities are moving into Ed. So initially this is, and probably something we haven't mentioned too at this point, even though we're going into this new structure at the beginning of the next fiscal year, it's not going to be like flipping a light switch. I mean, it will often use us here, or you'll hear us use the term, we're using 15 as a transition year. We're still working on some of these concepts. This, your question is actually one of those areas that we are continuing to work on. So from a ground test perspective, we moved the aeronautics, the ATP assets, within the program, but that's the starting base of where we are. So it's, to some extent, it starts off with a do no harm aspect to it. We don't want to undo something that has worked where we have seen a lot of success. We have seen, I think some of the areas where it's worked really well is when we've had a good correlation between what we've been able to do, especially on capability enhancements on the ground test side, with the research needs going forward. So we want to continue to enhance this. The way I would describe it is, ultimately we're going to have to have a balance. And first of all, it's going to be a balance between the maintenance and the new capabilities. And so these are part of the processes that we're going to be setting up. How do we analyze? How do we look at that? How do we perhaps draw that bound differently from the set of facilities that we now classically call our ATP facilities? Because some things that are in there may not necessarily be, the things that we need to move forward, both from a NASA and also from a community perspective. As much as, and the way I say as much as, because I think we can find, we've definitely got to the point where there's a use for everything that we have. But it becomes a prioritization exercise where there may be something that we definitely need more than something else that we have. How do we make that decision? And it's got to be a very deliberate and conscientious decision. So it's not something that we go into lightly. Those are the type of things that we're exploring right now. How do we set up the right kind of process to do the analysis and have that understanding? But I think we have to be willing to make those steps. If we're going to move into some of these areas, the different type of propulsion types, maybe more autonomy, whatever it has, we have to have that. We have to be able to say that we'll take a step, and maybe that means changing somewhat the infrastructure we have. But at the same time, we have to do that carefully because so much of what we have, the reason we have it today is because it's been so useful and it's gotten us to the point that we're at. So I would say it's a work in progress in trying to achieve that right kind of balance. But I'll stress it right up front. It's not an idea of saying, well, what can we do just to reduce the budget in this area? But it's how can we spend the budget that we have in the most efficient manner to do the research that we need to do so that we can achieve the capabilities that we need in the future.
So Jay talked about the ground test, and we're doing something very similar relative to our flight test assets and capabilities. I use the term due diligence. Quite honestly, being the product of Alabama public education, I'm not sure what that means. But the way I've been using it is audits, assessments, and analysis. So we're auditing what we have, we're assessing what we need, and we're analyzing then how we're going to pay for that and what we're going to do. So for flight, we basically invest about $25 million a year into those capabilities. I mentioned the 4 different classes, what's now the Dryden test range, our support aircraft, the loads facility, and our simulators at Armstrong. 2 of those, the simulators and the loads facility, very modest investments. But for the test range and those support aircraft, it takes a lot for that. And so we're going through an internal NASA assessment as well as paying for an assessment to look at other government agencies and industry and what the best practices are. So we're going to marry all of that. So we're doing that in this year, in 14. We're going to marry all of that and put together a roadmap of what we're going to do as far as activities. And Jay used the analogy of flipping a switch. We won't be flipping a switch, but we will be starting down a road to where I think in 16, 17, 18, we're going to be explicitly making these make-buy decisions on how we do this, whether we go and procure the capabilities that we need for the flight activities that we need to support, or are we going to have those in-house? I don't know what they are right now, but I do think that we put the right due diligence in place so that we will understand within the next year or so the right pathway that we should be on that will allow us to explicitly make those decisions in 3 or 4 years.
Greg Carr with Saab. I had a question for Ed. Under ISP, are you going to formulate new projects that are focused on specific technologies, like follow-ons to UAS or
Thanks, Greg.
ARA?
So yes and no. So yes, we will be. Actually, the part I didn't talk about because it's a little confusing. We have on our organizational structure something called future projects. So we will be doing that. We'll be advocating for them, and we will formulate them, and we'll make a decision making sure that it is the right place for those projects to reside. And so an example of that is advanced composites, which we had under ISRP and formulated that, we got it started and handed it off. And so we'll continue to do that type of work. But, Greg, it will not necessarily be a follow-on to ERA or a follow-on to UAS in the NAS. I would say more than likely that will not be what they are. We will look at opportunities to evaluate UAS and the NAS technologies as well as ERA-related technologies or from any other program in a relevant environment. And if that is something that is complex enough that we should be doing that, or it's flight-oriented, so we should be doing that, that would be a future project that we have.
And Ed's program isn't the only one that has future project lines. AOSP does, and there are others as well. The kinds of decisions that will be made around opportunities are, I expect them to be elevated to a mission directorate level. So as the ATD project that I talked about, as elements within that project, specific activities roll off, we will be looking strategically at the mission director level to understand where is the next best place for us to invest. It could be across any of the projects or any of the programs here. We want to make sure we're doing that as smart as we can, given our vision and adjustments to that vision and strategic direction going forward.
Yeah, I'm glad you answered that way. I didn't mean to imply I was asking about specific follow-on. I just
No,
in general,
that's fine. Yeah.
For Ed's project, that, yeah, I mean, obviously I would envision that IASP is more an umbrella under which other technologies could percolate out of the other programs, and then we're at the appropriate TRL level, or technology that's associated with flight tests, then you would pick it up and do something with it.
Yeah. Well, and some of that percolation in the movement may be from AOSP to IASP, may be from TAC to any of these efforts or to IASP. So there's a lot of movement, and again, we will be looking to do that as smartly and as strategically as we possibly can, given our level of investment.
So I was going to ask you,
Greg, you did make a good point that for IASP, it is cross-cutting across all the thrusts that Bob talked about, and so we could have efforts in any of those areas.
Which I think is the distinction and the point of the reorg is it's a shift in focus from what ISRP was doing, which was specifically focused on UAS and ERA. So John, to your point then, I'm curious with regard to the ATDs, which we talked about last night, that's sort of right now internally done between CTD and SAE, but all under ASP. Do you see more opportunities to do some of the ATD stuff in conjunction with IASP and ED and having NASA maybe run some flight demonstration programs?
It's entirely possible. As we are planning them right now, we are working within a set of partnerships that is external and driving them largely within the program. It does not preclude a larger effort. In areas of UAS, as an example, as we look forward, UTM, and as you were hearing perhaps yesterday from PK, at the level of planning that we're doing it right now, it is being captured in AOSP. But it may make sense as it matures and evolves to engage in a much more complex or integrated test environment that may very well be looking towards either assets that Ed has or a different kind of project that would fit, or sub-project that would fit under Ed. We aren't trying to make any black or white decisions now on where these things will be housed. We want to make sure we are doing the right development of concepts, maturity of technologies, and then pick the smartest and the best place within the overall portfolio to execute that transition to use in the system.
Mm-hmm. Another question here from the folks watching online. I think it's specifically about the state of maturity of blended wing body research and moving towards developing large capacity environmentally friendly airliner with a long range capability.
Well, I can at least start off with that. So, we flew and showed the flight qualities characteristics of a hybrid wing body as well as some of the noise characteristics. We continued, one of the things that we're doing as one of these demonstrators is getting high-quality noise measurements for engine airframe integration. And so we feel like that we have at least addressed part of this TRL valley of death in this area. And as far as where we're going to go after that, that's going to be up to not only NASA, but also the other interest from our industry partners on what they might want to see, the direction they might want to go, and what makes the most sense as far as matching those capabilities together in a partnering arrangement. So we've been very actively involved in 100 and how many flights did we do with the X-48 Bay? 130 plus flights with the X-48B and C. Very, very successful that we did, and we continue to use that as a platform because, quite honestly, to meet these stretch goals that we're looking at in ERA, we've identified that it's not only the technologies, but it's also the airframe. So it needs to be an innovative, a tube and wing airframe is not going to meet these goals. So it needs to be the technologies associated with an advanced airframe concept as well. And so that's one of the concepts that we've looked at. And we've done studies on that, explicit research on that, and we will continue in an appropriate way.
Yeah, and another way to look at this, this particular question goes back to one of the earlier ones, what's the coordination, between projects, who's doing what, and so clearly there's been a lot of work on a hybrid wing body configuration. Really, it's something that started in subsonic fixed wing. A lot of that graduated into ERA, and we'll show that, successfully demonstrate certain technologies, related to that. There are certainly aspects to it that are still being explored. So, for example, one thing that wasn't done in ERA, but what we are looking at is in some of the high Reynolds number effects. So we're looking at some of those configurations. How might we test those, for example, in the NTF to collect data to get an understanding about the configuration that we haven't yet explored in some of these other efforts. So another area where we're continuing to coordinate, if you will, moving forward, looking at advanced configurations. But of course, from a NASA perspective, we're not just solely looking at hybrid wing bodies. I alluded to truss brace wings. There's the D8 configuration and other things, that have been explored, amongst not just within fundamental aero, but also in ISRP. So, from the whole concept of new configurations, we're definitely looking at a wide variety of things, I would say.
We have a couple minutes left, so I wasn't sure if I would do this or not, but I guess I'll do something since it's. Hopefully, I won't get in trouble for it.
You're already in trouble.
Yeah, well, yeah. So this is from USA Today, January 1st, 2014, and they interviewed airline CEOs because it was the 100th anniversary of air travel. And these are some of the things that they said. So United, engine airframe technology could significantly reduce travel time, so supersonics. JetBlue, zero carbon travel. Branson, of course, no secret there, London to Sydney, or pick any 2 points halfway across the globe in under 2 hours, so suborbital flight. Frontier Airlines, local community-based air transport, some of the things we've been talking about with kind of PAV things, pilotless commercial aircraft. I love the Spirit Airlines because, the Google's put me there, technology, we don't need airlines no more. So I put it up there. So what are, part of what we're looking at is what are those big questions? What are those big challenges? How do we reconceptualize the future? So what do you guys think? Any ideas? We've been talking about this internally. If it's just NASA ARMD dreaming up big questions, that's not going to do it, right? We need the whole community thinking about what are those big challenges for the future? What are the big ideas? What are those concepts that we should, maybe new concepts to put on the table, or maybe concepts that have been around for a while that just weren't quite ready for prime time, but maybe with technologies as they're developing are becoming ready for prime time. So what do we think?
I'm Mike Logan. I'm
Hey, Mike.
NASA Langley. I was at a AUVSI conference last month, and there was a panel on civil uses of UAS. And they had done one a long time ago, I guess back in 2007-ish. And they were predicting, you know, what kinds of things would be used and so forth. One of the lessons learned from that was they said they completely missed the small UAS revolution. I guess my kind of question that goes along with this is, how do you see institutionalizing a method to keep from missing those kinds of things? You know, some of us have been kind of a lone voice in the wilderness on a couple of those areas. How do you see that playing out across the various, you know, projects and programs and portfolio as a whole?
Yeah, so I don't know that there's a way to do that, right? I mean, I think our attempt is in fact to explicitly put in something like TAC and CAS, where we're giving people the opportunity to both ask the question, you know, what is the big question? Because if you get the question right, it certainly helps people think differently about what the answer is. But also to say, hey, there's a new concept, and I think the difference is that it's really hard, as you and others know. I mean, it's hard to say, I got this great idea, but now it's competing against something that has a lot more, you know, behind it. And so the idea with TAC is let's take a little bit of time, take a little bit of money, and see if it's feasible. Let's do the studies. Let's do some experimentations, even some flight if we can, and see if that might happen. So I think it's not perfect. It's, as Doug said, it's an experiment, but it's, I think, what at least partially we're trying to do to address that question. I don't know, Doug, if...
Nothing to add. I think you hit it right on.
Yeah.
You know, but I would add one thing to that. I think one thing we also have to look at is what is, you know, in these revolutionary advances and the things that, you know, that we see coming up in the future, what is also the NASA role when, you know, in making that take place? So using the UAS as an example, I clearly think there is a NASA role even on the vehicle side where we can have an impact and there's things that we should do, but it doesn't necessarily mean anything. And one of the reasons for that is, especially for the smaller vehicles, there's a much lower a bar for entry, you know, into this. You know, you don't need to have a factory, you know, a team of 100 engineers in order to build some of these vehicles. I mean, we see it happening all over, you know, within small businesses, within universities, so on and so forth, of where the innovation is coming out. But then it makes us also answer the question, where's the right government role to play? So for something, for example, like the UTM concepts that John, I mean, that's the kind of thing that will bring it all together and help make some of these other advances possible. So I think it's, to some extent, we've got to also understand where that barrier to entry and where we can have the right kind of impact. But I would go back and say there is certainly no crystal ball to make it happen, but we need to be aware of it to the greatest extent, and ideas on how to better to do that we're also open for as well.
And this is kind of a cop-out answer, but I'll pick on Mike's words specifically. Institutionalize. I don't know if this is something that we can or should institutionalize. I mean, again, maybe I'm just picking on the words, but that speaks to a structure, a process, or rigidity that I don't think lends itself to us staying ahead of the curve in terms of the new disruptive opportunities. So as I say that, I don't know how we then put something in place, build the culture that will allow us to be able to be open to see these things. But I mean, I'd try to walk away or step away from things that even sound or feel like institutionalizing an approach to making sure we don't miss this.
Yeah, stuff. And I think if you include in institutionalization the idea of values, culture, you know, ways of doing business, things like that, I think that in that way you can try to institutionalize. If it's a process, you know, specific, you know, set of approaches and so forth, that's a much harder thing because it's not, you know, these kinds of things don't lend themselves to, you know, to popping out of some, you know, disciplined analysis.
Yep.
You know, but you have to have that value system that says we're gonna think about it, open it, and care about it.
Yeah, I think the thing that, you know, if we really had that answer, Mike, we wouldn't be sitting up here as federal employees. But But if you go back to early on when in Bob's presentation, some of the rationale and the impetus around this restructuring was flexibility. And so it's the flexibility to adapt to those changes and to those things that are trends that you may not really pick up on as they happen, and that we are not so inflexible in our structure or the way that we're doing business that we can't do that in a way that will foster innovation as these new, whether it's a new trend, a new technology, whatever it is, that as that raises its head, that we can adapt to it, we can support it in things like TAC and CAS, and that we can mature those then as appropriate.
So intellectual and organizational agility is principally what you're kind of referring to as more buzzwords. Thank you very much.
Exactly. David?
David Ballard again. One thing I don't see, except perhaps a bit in Dave Barger's comment, all of these are about things that have gotten cooler and cooler, farther, faster, sleeker, but there's no mundaner and mundaner, which is more and more people traveling every year to more and more places as a matter of routine. And for the future to continue to enable that, it means you have to have more and more airplanes getting closer and closer together, in an environmentally safe way, which is something that cuts across all of your programs, that has to be done safely. And I think it's that aspect of aviation that has made the enormous difference in the world economy. I mean, the cool stuff is great, but it's the mundane stuff that keeps the industry alive. And a lot of the sessions here are about that more than they're about cool things. Yeah. Getting around weather, getting into airports.
It's a really interesting point. I think an important place to put in an important message, which is I think it's not, when we talk even about TAC-CAS, it's not necessarily just about here's a really cool idea. It may be about this might be really mundane, but it's a really tough problem. And how do we, and we've got a view about how we go from where we are today to solving that problem. But maybe someone's got a different idea about how to solve that problem, and it's that too. Mm-hmm. So it may be just a different idea for what appears to be a very mundane problem. And we can't lose sight of that either, that it should be inclusive of both ends of that spectrum.
One way I've often thought about how the future being better is that if in 20 or 30 years the experience of air travelers is about the same as it is today, that would be fantastic because there'd be so many more travelers doing that. It wouldn't be the coolness of the experience increasing, and increasing the coolness would be great. But if you double the number of people, you've also accomplished a lot.
Yeah. Right. Yeah. But I would also just make a point. I would say mundane is also in the eye of the beholder as well, because some of the things that, quite frankly, outside of the, an environment like this conference may not really appreciate, say, some of the work that we're doing on the work that we're doing on some of the more foundational aspects. Like some of them don't even know what CFD is. But when we can still have that exciting future view of something maybe we've been working for a long time, but we're continuing to grow and expand it, I think it's up to us to also keep the energy behind it and explain to folks maybe why it isn't mundane.
Well, looks like we are a couple minutes over, so I just want to thank my colleagues, the panel members. Thank you. And I'd also like to thank the audience for being here on Friday and for sticking around for 2 hours, and I hope your World Cup team is still in the competition.